Okay, right before the last final exam, we covered our last piece of content, which was just graphing sine and cosine. And so we looked at these two graphs. Y is equal to a sine of bx, and y is equal to a cosine of bx. Those were the two that we looked at. Now we're going to add some changes to it. We're going to create some horizontal and vertical shifts. Now the amplitude is still the absolute value of a. That always stays the same. On the test, everybody can identify the amplitude. You just have to take the absolute value of the front number. The period, you take 2 pi and divide it by b. So whatever the number in front of x is, you take 2 pi and divide it by that. The vertical shift is just d. So whatever number is on the end, that's your vertical shift. Oh, that's why I ran an extra. And then we've got horizontal shift. You will solve bx minus c is equal to 0. Solve for x. And that's your horizontal shift. Okay? Now, it may not make a lot of sense right now, but trust me, it will as we move forward. Okay? It will as we move forward. bx minus c is equal to 0. That's this inside piece. You're going to solve that inside piece equal to 0. Whatever you get, that ends up being your horizontal shift. Okay, flip it over. Let's try 4 examples. Okay, you always do it in this order. I've taught this many times, and I used to not teach you like this. It was complicated. Now it should be a piece of cake. You always start with the vertical shift. Vertical shift, amplitude, period, and then horizontal shift. So this order is what you apply it in all the time. Now, I'm not going to do letter A first because letter A actually has a horizontal shift. I'm going to go over to letter B because letter B is a little bit easier, okay? So I have a vertical shift, I have an amplitude, I have a period, and I have a... Let's take off. All right, so we got vertical shift, amplitude, period, and horizontal shift. By the way, they schedule those. They're mandated by the state to have a certain number of fire drills during the course of the year, and so that's what they do. And they try to pick nice days to do it. So today was a nice day. Okay, so we start with the vertical shift. The vertical shift is always the number on the end. Okay, so just be 2 units. And what that means is instead of being centered around the x-axis, it's centered up 2 units. Now I'm also going to identify my amplitude. Amplitude is the absolute value of the number in front of cosine or sine. So it's going to be 3. So from my vertical shift, this is what people got confused with last year. We'll make sure you get it. From your vertical shift, you're going to go up 3. And from your vertical shift, you're going to go down 3. So if you go up 3 from your vertical shift, what's your highest spot going to be? If you go up 3 from your vertical, 5. So 1, 2, 3, 4, 5. So that's my maximum spot, 5. If I go down 3 from my vertical shift, where am I going to be? -1. So you can see, and I just draw this axis right down the middle, okay? That's my vertical shift. And from there, I'm going to go up 3 to 5, and I'm going to go down 3 to -1. So everything shifts up 3 units, or up 2 units. We're okay with that? Next thing is I identify the period. For the period, I take 2 pi, and I divide it by the number in front of x. What's the number in front of x? 1. So I get 2 pi. And I just divide that up into 4 spots like I normally would. Why do I divide it up into 4 pieces? 4 quadrants. Okay. In order to have a horizontal shift, there needs to be something on the inside. So there is something on the inside. But here, there's nothing on the inside. You would literally be setting x equal to 0, and you would come up with 0. There is no horizontal shift, none whatsoever. Now we graph it. Where does sine, or where does cosine start? The max, the min, or the middle? Cosine likes to start at either the maximum or the minimum. It does not start in the middle. Sine starts in the middle. Since it's positive, it's going to start at the maximum. Where's it going to go from there? Down. It's going to cross over right here. And then it's going to bottom out. And then back up. What do you think? Not too bad, huh? See how it shifted a little bit differently? I mean, I could take the shape and I could move it so that it would fit kind of like how we normally used to see it. But right now it's all shifted up 2 units. Okay? Let's look at one that has a horizontal shift. Here, the vertical shift, there's nothing on the end of this sine of x. So the vertical shift is 0. What's the amplitude? There's a 1 in front of the sine of x, so we say it's a 1. So from the vertical shift, we go up 1, and from the vertical shift, we go down 1. So what's going to be the highest spot of this graph? And the lowest spot? To get the period, I move, or I take 2 pi and I divide it by 1, which is 2 pi. So I'm going to mark off 2 pi. And divide up into 4 parts for my 4 quadrants. And now I'm going to identify the horizontal shift. I take the inside and I set it equal to 0. What do you get? X is equal to pi over 4. If I have a horizontal shift, I do something different. I do these 3, and then I stop and I sketch. I call it a ghost graph. A lot of people really struggle to make the horizontal shift appropriately. So what I'm going to do is I'm going to sketch a ghost graph. That's what the graph would look like without the horizontal shift. So let's not think of the horizontal shift right now. Let's sketch everything but the horizontal shift. Sine, is it going to start at the max, min, or middle? Middle. Is it going to go up or down? Okay, and I'm only going to draw dots here, okay? I'm going to draw a dashed graph that I call a ghost graph. So that's not the real graph. That's just the graph that's going to help me sketch the real one. What is my horizontal shift? Pi over 4. You tell me, how much is pi over 4? Is it 1 tick mark? Is it 2 tick marks? Is it less than 1 tick mark? How much is pi over 4? It's half of pi over 2. So it's going to be half of a tick mark. So here's what I do. I take all these dots and I move them half of a tick mark to the right. And then I could draw my real graph. So the blue graph should look exactly like the green graph, just shifted pi over 4 units to the right. And that's why I draw the green graph, the ghost graph, to help me make that sketch more accurately. Okay? Now I'm going to stop there, and we're going to pick up with the other two examples tomorrow. And I'm going to hand you the worksheet that we're going to do tomorrow in case you want to try to give it a shot tonight at all.